Okay, we are going to be looking at modular arithmetic. This is arithmetic of remainder. So anything we are doing in this topic is all about finding the remainder when something is being divided. Some of the used symbols are these, talking about when they're equivalent or congruent. Then we have this. The reason why this is circle is because it's revolving, it's cyclic, and this for addition. So these are the commonly used symbols. So we have a question here. The first question here, we have copy and complete the multiplication table in modulo 5. If you are talking about a given mode, for example, mode 5, the short form is mode 5. The numbers are allowed there are the numbers less than that number 5. For example, mode 5, the numbers allowed there are from 0 to 4. Mode 6, 0 to 5. Mode 7, 0 to 6, and so on and so forth. But when you are giving a question, you have to follow the instruction there. So we have in modulo 5 on the set 1, 2, 3, 4. So we are given this table to copy and complete it. So we are going to solve it and complete the questions there. You can see some of the values we are giving, so we have to complete it ourselves. This is multiplication, they are multiplying. That is 1 times 1 is 1. 1 times 2 is 2. 2 is less than 5, so I have to write 2. 1 times 3 is 3. 3 is less than 5. That's why it was left like that. 1 times 4. 4 is less than 5. So once it's up to 5 and above, we have to take the remainder. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 6 is more than 5. 5 going to 6 is 1 remainder 1. So we'll take the remainder 1. 2 times 4 is 8. 8 divided by 5 is 1 remainder 3. We'll take the remainder 3. 3 times 1 is 3, correct? 3 times 2 is 6. 5 going to 6 is 1 remainder 1. So we'll take the remainder 1. 3 times 3 is 9. 5 going to 9 is 1 remainder 4. 3 times 4 is 12. 5 going to 12 is 2 remainder 2. That's why there's 2 here. 4 times 1 is 4, still less than 5. This one is already given, which is 4 times 2 is 8. 5 going to 8 is 1 remainder 3. 4 times 3 is 12. 5 going to 12 is 2 remainder 2. Then 4 times 4 is 16. 5 going to 16 is 3 remainder 1. And that is how we got this one. You can see from here, we have completed the table. We are good to go. With this table, to solve this question is very easy. So let's go to BI. They ask you, solve the expression 2x times 4 is equals to 3. What they are trying to ask you here is that 2 times, what number should be here, that when you multiply it by 2 and multiply by 4, that will give you 3. Let us take it. Remember we have 1, 2, 3, 4 here. So when n is equal to 1, this is like 2 bracket 1 times 4. 2 times 1 is 2 times 4. No need of trying to use your, just go to the table there. 2 times 4. 2 times 4 give us 3 is equal to 3. So our n is 1. Can you see that now? So it met the condition that was here. Okay, let's try other ones. When n is equal to 2, this is like 2 bracket 2 times 4. 2 times 2 is 4 times 4. What is 4 times 4? We have 1 and 1 is not here. So this n cannot be equal to, n cannot be equal to 2. Because if we do that, what we are going to get as our answer is 1 and 1 is not here. Okay, let's try 3. When n is 3. So this cannot be, what I'm trying to say is that it cannot work. So let's try when n is equals to 3 in this formula. 2 bracket 3 times 4. 2 times 3 is 6 times 4. We don't have that. So once you get this, you can stop at that point. But 6 times 4 is 24. 5 going to 24 is 4 remainder 4. And 4 is not here. And so on. So let's go to the second one. I. Find the value of n for which 2 times 3 as there is n is equal to 2. So let's start with this bracket first. So let's go to this. Let's try 1. 3 times 1. 3 times 1 is 3. So this bracket will give us 3 when we use n as 1. Then 2 times 3. 2 times 3 is 1, and 1 is not here. So n as 1 cannot work. Let's try 2. 3, when n is equal to 2, let's try it. 3 times 2 is 1 in this table. Then 2 times 1 is 2. So n is equal to 2. And that is how to solve it. So expect at least 1 or 2 more questions in the next video. Thank you.